How does the amplitude of a wave change when it encounters another wave? This is the question students explore in Investigation 15C, Interference. When multiple waves exist in the same place at the same time, interference occurs. Wave interference can be either constructive or destructive, causing the amplitude of the resultant wave to be different than the individual waves. In this investigation, students will observe the interaction of wave pulses on a spring and draw a conclusion about when constructive and destructive interference occur in waves. Stretch the slinky out flat on a table or the floor with one group member holding each end. Move your hands sharply side to side or up and down to send transverse wave pulses down the slinky. Students will send pulses down the slinky from each end simultaneously and observe how they interact when they meet in the middle. Students will test scenarios like equal pulses from each end, a big pulse from one end and a small pulse from the other end, equal and opposite pulses from each end, opposite meaning the peaks of the pulses are on opposite sides of the slinky, and a big pulse from one end and an opposite small pulse from the other end. The pulses travel fast, making it difficult to observe the exact moment they interact, so students are encouraged to use a slow motion video to make their observations. If students don't have access to slow motion video, they can use the video samples on the 15C investigation page in the student ebook. Students should recognize that the amplitudes of the wave pulses add together when they meet in the middle of the spring. Pulses on the same side add to make a larger amplitude. And pulses on opposite sides combine to make a smaller amplitude. The pulses completely cancel out if the amplitudes are equal but on opposite sides of the spring.